class, in this video we're going to be going over prime numbers. The learning intention for this particular video is we're going to know what prime numbers and composite numbers are. We're going to be able to determine whether a number is prime by considering all of its factors. And lastly, we're going to be able to find the prime numbers of a given number. So firstly, we're going to look at the first aspect, which is about prime numbers. So the definition of a prime number is a positive whole number that has two unique factors. So as you can see by this particular statement or this definition, there are two requirements or two conditions for a number to be considered as prime. Firstly, it needs to be a positive whole number, so a positive number like positive 5, and also it needs to be a whole number, so you can't have any decimals at all. And secondly, it needs to have two unique factors, itself and 1. Another way of describing this particular definition is a prime number is only divisible by itself and 1, so there's no other numbers can be divided into it other than 1 and itself. Or lastly, if that doesn't make any sense to you at all, that means any prime number is considered prime when the only factor pair is 1 and itself. These are 3 different ways to explain what a prime number is. So let's look at some examples over here just to solidify your understanding. So firstly, 17. Is this number considered to be a prime or not a prime? Well, we know that the number 17 has only 2 factors. There's only the numbers 1 and 17 that is divisible by the number 17. As a result, the 17 is classified or considered to be a prime number. Let's look at the second example, number 20. So in this case over here, what numbers can be divided into 20? So in this case over here, you would agree with me that 20 has the following factors. It has 1, 2, 4, 5, 10, and 20. Now, we said a number is only considered to be a prime number when the only factor pair or the only numbers that are divisible by that number is 1 in itself. As a result, 20 is not considered to be a prime number since it has more than 2 factors. If it only had 1 and 20, then in this case it would be considered as a factor, but in this case it wasn't. Since it has these other factors here, it's not considered to be a prime number at all. Let's look at other examples to see whether they're classified as prime numbers or not. So the number 0.5. Now remember, we said a prime number has to meet 2 conditions. It needs to be a positive whole number and it has to have 2 factors. In this case, if 0.5 is not a whole number, so therefore this is not considered to be a prime number at all. And for the last example on this slide, 23, we need to think of all the factors there are. And if it has more than 2 factors, which is 1 and 23, then it's not considered to be a prime number at all. So in this case of here, 23 only does have 2 factors, 1 and 23. So as a result, 23 is considered to be a prime number. Now, this is a pretty hard question, or not hard question, but this is a common question that I often get asked, and many people are often confused about this. But is a number 1 considered to be a prime number or not? Let's look at the definitions again of what a prime number is. We said it must meet these 2 requirements. It needs to be a positive whole number, which it is, so therefore it does meet this first component. But does it meet the second component, which is it has to have 2 unique, meaning it has to have 2 different factors, 1 and itself. In this case over here, the only factor pair of 1 is 1 and 1, and because it's the same number, it only has 1 factor in this case. As a result, it doesn't meet this requirement, and hence 1 is therefore not considered to be a factor at all. Now, what we're going to be looking at is the divisibility test to check for the prime number. So this is relating to the previous lessons, and I've previously shown you all these different ways for us to quickly check to see whether a number is divisible by the numbers 1, 2, 3, 4, etc., etc., with the exception of 7, since there's no easy divisibility test for the number 7. So let's look to see how we could actually use what we learned from the previous lesson to test whether a number is a prime number or not. So the first number is 67. Is it divisible by 2? Okay, so what we're doing is if it is divisible by any one of these numbers over here, this would automatically state that 67 is no longer considered to be a prime number since it has a factor other than 1 and 67. So firstly, if this was divisible by 2, remember we said all numbers that are even are divisible by 2. In this case, 67 is an odd number, so it's not... in this case, 2 is not a factor. is it divisible by 3? We said that to test whether 3 is a factor or whether 3 is divisible is by adding all the individual digits in the number. So what is 6 plus 7? That is equal to 13. And we find out whether that sum is equal to can be divisible by 3 or not. In this case, 13 cannot be divided by 3 as a nice whole number. That will give you 4.33333 recurring. As a result, 3 is not a factor at all. We said when something is divisible by 4, the last 2 digits of a number is divisible. In this case, 67 is not divisible, so you can put that into your calculator and test for it, and that will give you a decimal number. Therefore, this is not divisible by 4. We said something is divisible by 5 when when the last digit is 0 or 5. In this case, it isn't, so therefore, this is not divisible. We said something is divisible by 6 when when it passes the divisibility test for the numbers 2 and 3. In this case here, since they both failed, therefore this is not divisible by 6. Skipping number 7 because remember there is no easy test to see whether something is divisible by 7. So we're going on to 8. We said something is divisible by 8 when the last 3 digits of the number is divisible by 8. In this case, there's only 2 digits over here, and that is not divisible by 8. So therefore, this is no as well. Is this divisible by 9? The test to see whether something is divisible by 9 is, again, add these 2 numbers together, which gives you 13, and find out whether 13 can go into 9, which in this case it isn't. And lastly, is it divisible by 10? Well, it doesn't end with a 0, so therefore it doesn't. Therefore, since it doesn't pass these divisibility tests, this indicates that 67 is a prime number, and the only factors that go into 67 is 1 and 67. Alright, time to check for your understanding, so please pause the video right now to see whether you got the answers correctly. So the question reads, which of the following is classified as a prime number? So remember, something that is considered to be a prime number, it needs to have a positive whole number, and it also needs to have only 2 factors. In this case of here, we said 1 is not considered to be a prime number, so we can rule that out. Is 4 considered to be a prime number? So let's list down all the factors of 4. In this case, there's 1 times 4, so that's a factor pair, and there's 2 times 2. Since it has more than 2 factors, therefore 4 is not considered to be a prime number. Is 11 a prime number? List down all the factors in this case. And in this example over here, there's only factors of 1 and 11. Therefore, C is going to be the correct answer. So therefore, 11 is considered to be a prime number. Yeah, what I'd like you to do for the next 10 minutes is, firstly, I need you to please copy down this particular grid over here inside your exercise book. Once you've completed drawing the grid in your exercise book, what I'd like you to do is to either shade in or just tick the first 10 prime numbers on the number grid. So pretty much what you're trying to do is identify the prime numbers from 1 all the way to 100 over here. And just a reminder, we said a prime number is a positive whole number, which they all are, but they also need to only have 2 factors, so 1 and itself. So please pause this video right now so that you can answer the questions, and afterwards check to see whether your answers matches my answers. Alright, by now you should have already completed the questions after 10 minutes, so let's now review to see whether the answers you got matches the answers that I have. So firstly, the first prime number should be 2, the second one should be 3, next one is 5, 7, 11, 13, 17, 19, 23, and lastly 29. So these are the answers over here. If you wanted to extend yourself, then you can also list down or shade all the other prime numbers that are found in this list over here. And if you did that, then this is the answer that you should have. So this slide over here summarizes all the prime numbers for all numbers starting from 0 all the way to 100 over here. So everything shaded in yellow are all prime numbers. Alright, we're going to be looking at the second aspect of today's lesson, which is about composite numbers. Now, if you understand what prime numbers are, understanding or composite numbers is pretty much very easy to understand because they're the exact opposite of what a prime number is. So since the opposite of prime numbers, composite numbers is a number that has more than 2 factors. We said that prime numbers only has 2 factors, 1 and itself. So therefore, since composite numbers are opposite, if it has more than 2 factors, therefore it's considered to be composite. So let's look at these 2 examples over here to see whether they're considered to be composite numbers or not. So look at number 18 over here. What numbers can be divided into 18 as a whole number? In this case over here, you would agree with me that 1 and 18 can go into 18, but also 2, 3, 6, and 9. And since there has more than 2 factors, 18 is therefore considered as a composite number. And in the example number 24, 24 also has multiple factors as well. It has 1, 2, 3, 4, 6, 8, 12 as well as 24. And because it has more than 2 factors, therefore 20 is also considered to be a composite number. What I have on this slide over here is a very nice summary that kind of shows you all the prime numbers and composite numbers for the first 100 numbers. So everything, as you can see, colored and shaded in the pink-purple colorway are all the prime numbers. Everything colored in the nice minty green colorway is considered to be all the composite numbers. And the only number that is not a prime and not a composite is the number 1. It's time for us to test for our understanding. So which of the following is a composite number? So please pause the video right now so you can answer this question. Once you get this question, or once you got the answer, then please resume the video to see whether your answer is correct. In this case over here, is 2 considered to be a composite number? Well, 2 is not a composite number because 2 only has 2 factors, 1 and 2. So therefore, this is a prime number. 17 also has 2 factors, 1 and 17. 29 only has 2 factors. So therefore, the last example, the correct answer is going to be D. So 30 is going to be the answer because 30 is composites because it has factors 1, 2, 3, 5, 6, and 15 and 30. It has multiple factors, therefore it's considered to be a composite number. Our second example, which of the following is not a prime number? So please pause the video right now. So essentially the question is asking, because it's not a prime number, it's asking you which of the following is a composite number. So we need to look for a number that has more than 2 factors. So the best way to start off is to see whether they are even numbers. Generally, if it's an even number, it's considered to be a composite number. All these numbers over here are odd numbers, so we can't really find that out. But you should identify which of the following numbers has more than 2 factors. In this case over here, the answer should be 27 because it has the factors 1, 3, 9, and 27. As a result, this is considered to be a composite number. What I'd like you to do now is I'd like you to answer these questions over here. So answer questions 1 and 2 first. And you do need to answer every question, so please do not skip any questions. It should take you around 15 minutes or so. So all you're doing for these 2 questions is stating whether they're considered to be a prime number or composite number. I really do want you to please show me all your working out for your answers that are composite. So for instance over here, B is the answer of this is going to be a composite number. 24 is a composite number. And if it's a composite number, I do want you to list down all the factors of 24. So for instance, the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. This is just really good practice so that you can still recall and improve your understanding of factors. So for all the answers that are composite, please do include and list down all the factors, as this will improve and help with your revision as well. These are the answers over here. So hopefully you guys got the answers correctly. All right, we're now looking at the last topic of today's video, which is about prime factors. A prime factor is considered to be a factor that is also a prime number. So let's look at this example up here so you have an understanding what prime factors are. The question reads, what are the prime factors of 6? So what we're going to be doing first is, the first step is we're going to list down all factor pairs of the number. Okay, so what 2 numbers multiplied with each other gives you the answer of 6. In this case of here, you would agree with me that 1 and 6 are a factor pair, and 2 and 3. These are all the factor pairs of the number 6. The second step is we're going to choose down the prime numbers. So out of this list over here, what are the prime numbers? In this case over here, you'd agree with me that 2 and 3 are prime numbers. 1 we said is not considered to be a prime number at all because 1 only has 1 factor, and 6 has more than 2 factors. Number 6 is divisible by 1, 2, 3, and 6. As a result, the only prime numbers out of this list are 2 and 3. Therefore, the prime factors of 6 are 2 and 3. We're now going to be looking at a second example. So the second example reads, find the prime numbers that are factors of 30. So again, we're going to do the exact same thing where we list down all the factor pairs of the number 30. In this case, the first one would be 1 and 30. So 1 times 30 gives you 30. Another pair of factors that gives you 30 is 2 and 15, 3 and 10, and 5 and 6. So these are all the factor pairs of the number 30. After we've listed down all the factors, what we need to do is from our list, identify the prime numbers that are present. So in this case of here, 1 is not considered to be a factor. 30 is an even number, and all even numbers are not prime numbers, so this rules that out. 2 is a factor, so that 2 in this case is a prime number. 15 is not considered to be a prime number, since 3 and 5 can also go into it, so we can eliminate 15. 3 is considered to be a prime number. 10 is also divisible by 2 and 5, so it's not considered to be a prime factor. 5 is considered to be a factor, and 6 is not considered to be a prime number at all. So therefore, our answer for this question is 2, 3, and 5. So just lastly, write down a statement. So the prime factors of 30 are 2, 3, and 5. So it's time for you to test your understanding to see whether you can identify prime factors yourself. So the question reads, what are the prime numbers that are factors of 36? So please pause this video right now to see whether you can get the answers yourself, and then resume the video. So these are my factors over here, the factor pairs of 36. So you've got 136, 2 times 18, 3 times 6, 4 times 9, and 6 times 6. Again, what we do is we need to identify all the prime numbers from this list over here. In this case, it would be 2 and 3. So therefore, the prime factors of 30 are 2 and 3. Okay, class, it's time for you guys to now answer some textbook questions just to solidify your understanding. So I want you to please answer the remaining questions over here as indicated by the checklist. However, the only questions that I want you to get up to is from questions 1 to 6. So you've answered questions 1 and 2 already. I want you to answer 3, 5, and 6. These questions over here, 8 and 9, they're a bit more challenging, so you don't have to do these questions at all. But if you like an extra challenge, then please answer these questions. Now, question 5, sounds a bit complicated, and it reads, the following are not prime numbers at all, yet they are the product of 2 primes. Find the 2 primes for each of the following numbers. Now, if that doesn't make sense to you at all, essentially, question 5 is asking you to find out what 2 prime numbers multiplied by each other gives you 55. So essentially, that is what the question is asking you to do. So if you need any questions, then please ask me for help. These are the answers that you should get for the following questions over here. Lastly, I want you to please go onto the exit ticket that's found onto Google Classroom, so as this will allow me to gauge what your current understanding is and to see whether I need to support you in our next lesson. This is the end of today's video. Thank you guys for watching. I'll see you in the next video. Bye.